Alright, this is practice exam section 2, part A, and this one we're going to do number 2. Most of this one is done on your calculator. I am going to try my best to get the camera where you can see the calculator. If not though, just you can work along by just listening to me narrate. I'm going to narrate everything that I do with the calculator. Okay, but it says the temperature of a liquid at a chemical plant during a 20-minute period is given as G of T is 90 minus 4 tangent T over 20. And the time period is between 0 and 20 minutes. So it says sketch the graph of G on the provided grid. Now, you can graph this on your calculator, and we are about to do that. The problem is you won't be able to read the specific numbers. So what you need to do is just type in the function to your calculator, 90 minus 4 tangent T over 20, and let's plot it at what is it at 0. Okay, so I've typed in the function. Oops. And so at 0 over 20 it is 90. So we'll plot that. So at 0 we're at 90. I'm going to type in 5 over 20. Okay, and that is 89.97, or excuse me, 88.97. So I don't think you have to be perfect, but you know, something like that. Then I'll type in 10 over 20, so I'm just typing over the numbers, so that I got 87.81 when I did that. Okay, so at 10 we're looking at, you know, a little under 88. And then I typed in 15 over 20. That's 86.27. Alright, so something like that. And then finally 20 over 20, which is just 1. And you get 83.77. Okay. So plotting that, 83.77, you know, something like that. So what you've got is this descending curve, which you could see if you plotted it, but I don't know that you could get the specific points very well. Okay, so that's part A. Just plug the numbers in and plot it. Part B says, what is the instantaneous rate of change of temperature of the liquid to the nearest, oh, and then it says, excuse me, what is the temperature of the liquid to the nearest hundredth of a degree when the Fahrenheit is 10? Okay, so we already did that. When it was 10, it's 87.8148. So at 10 minutes, 87 point, so you just go back and look at your calculator, 0.8148 degrees Fahrenheit. Alright, part B says, what is the instantaneous rate of change? Okay, so there's a couple ways you could do it. You could do the calculus function, go to calculus, take the derivative, and then go back and retype that function and type in a 10, okay? But because the instantaneous rate of change, we're going to have to take the derivative. But I want to show you how you can do this by graphing it. So let's go to the green F1. I've already typed it in, so pause the video and take a second to type in 90 minus 4 tangent x over 20. Alright, and then I want you to hit F2 and zoom out. Okay, if you zoom standard, you're not going to be able to see it. So F2, zoom out. So that's 3. I have no idea if you can see that, but we've got something, we've got that curve that goes down. And what you do to figure out what is the value of the derivative at 10, go to F5, and then if you go down to option 6, it says derivatives. And it says dy dx, just hit enter. Alright, and then what you do is just type in 10. If you hit 10, it'll automatically put that in the x coordinate. Hit enter, and it gives you the value of derivative is negative 0.2597. Negative 0.2597. Alright, so you could just write for this one g prime of 10 is equal to negative 0.2597. Since you get to use your calculator, you don't have to find the derivative. But if you wanted to, you could just simply go to F3 for calculus and type in this function 90 minus 4 tangent x over 20, and it would give you a secant squared. It would be minus 4 secant squared x over 20 times 1 over 20. But it didn't say that. It says what is the instantaneous rate of change, and g prime of 10 is that, and that should do the trick. Alright, part C said what values of T is the temperature of the liquid below 86. Alright, so what you've got to do is figure out where on this graph do the two cross. So if you go back, go back to your graphing and have a second graph of y2 is equal to 86. Okay, I don't know if you can see that. y2 equals 86. And then do F2 and 3 for zoom out, and it'll draw that straight line, y equals 86. And now we just want to know where those two cross. Okay, so what you do is you go to F5 and go down to intersection, which is 5. First curve, just hit enter. Second curve, hit enter. It's on the second curve. Lower bound, go to the left of the intersection and hit enter. Doesn't matter where. Upper bound, go to the right of the intersection and hit enter. And it'll tell you they intersect at 15.708. Okay, so at what values is the temperature of the liquid below 86? When T is greater than 15.708. Alright, 15.708 minutes. And then part D says during the time within the 20-minute period when the temperature is below 86, what is the average temperature? Okay, we got to remember this 15.708 value, so I'm not going to erase that. But you're going to use your average value formula. We know that the average value is equal to 1 over, okay, and this is when it's greater than 15.708. So when it's so it's going to be 20, that's the top value, minus 15.708. And then we're going to integrate from 15.708 to 20 of the function 90 minus 4 tangent t over 20 dt. Now go ahead and try that. Put that in your calculator. And when you do, okay, and you can go ahead and simplify it, put whatever that value is, that 1 over 20 minus 15.708, that's like 1 over 1/4, right? Just a little bit more than that. But when you put it in your calculator, you'll get 84.9851. Right, degrees Fahrenheit. So this is a good one for calculator practice. So really go through this one, give it a try. Even if you couldn't read my calculator very well, go back and listen as I narrate it, and see if you can do those. And if you struggle with that, just shoot me an email, and maybe we can FaceTime, and I can show you how to do that one a little better. All right, that ends the video for number 2.